Welcome back. This is Maxime Dupuis. Today we'll do Project Euler number 25 using TDD, test-driven development. So, as usual, I did not read the problem beforehand, so we'll jump in together and try to figure out on the spot. So here's my screen, and here's the number 25, the 1000-digit Fibonacci number. Fibonacci sequence is defined by the recurrence relation Fn equal Fn minus 1, Fn minus 2, where Fn... Yeah, so we all know the example. We saw them in planning poker and everything. The first 12 terms will be this. The 12th term, F12, is the first term to contain 3 digits. Yeah, that's right. What's the index of the first term in the Fibonacci sequence to contain 1000 digits? Okay. So I guess just have to keep computing them up until the point where we hit the number of digits required. So how will we TDD this? We'll first make the easy test, count the Fibonacci, I guess we could call it like get the first Fibonacci number with n digits, and the parameter will be 1 digit and it will return 1. Oh, we're looking for the index, so it's the first one, and then the first one with 2 digits would be 7 and 3 digits 12. So we got our test cases already. Let's jump in and code them. So we get the index of how do you write that? Fibonacci to see. Get index of Fibonacci number of the first Fibonacci number with n digits. With 1 digit, we expect it to be the first one. I'll sort this, and we add the first with 2 digits and 3 digits, and 2 digits was the 7th. We expect this to return 7 and 12. So we don't really care about the value, we just want the index. And we make sure that the index starts at 1. That was our mistake in the last video. We lost a lot of time. So it doesn't start at 0, it starts at 1. So our test reflects that requirement. This is good. I think that's all we need, and then we can write the main once this test will pass. So with n digit, yeah, let's call it n. Move it to the source folder. Get in there. Move it in front of the main. Okay. And I guess we still need to find the Fibonacci itself, the Fibonacci number itself, because if we don't have it, it will be pretty hard to know how many digits there is. So actually we'll have a test for this first. Get Fibonacci to see, we said before, number. Function of the test, get the first one, and it should be 1. Now get a couple of them. 1 1 2 3 5. 1 1 2 3 5 and 8. These are the 1 2 3 4 5 6th numbers. function, the end Fibonacci number. Same thing, we'll move them to the source folder and start with this one. So now if we run the test, we expect to have 2 failing tests, and the one that we care about is get Fibonacci number, this one. So the usual way to do this is to use a recursive function. So we'll return the n minus 1th number plus the n minus 2 number. This is the return, and we have to have a stop condition. So if n is 1, return 1. And if it's 2, we need to have a n minus 2 number. So I guess if n is 1 or n is 2. And so if we want the third one, we'll ask for n minus 2. It will be 1, and 1 will return 1, and 2 will return this. So I think that's all for the Fibonacci number, and it passes. Now the test that doesn't pass is the get index. So I guess we can iterate through the numbers for P in range. There's no stop, right? So while true, or I guess let's do it like this: number of digits starts at 0, and as long as the number of digits is not equal n, so if we're asking for 1 digit, when as long as it's not 1 digit, keep trying the next number. So p I equal 0. Some digits equal, let's first get the Fibonacci number. Fibonacci number is get Fibonacci number of I. So if we're looking for, let's say, the third number, it will give us 2. So 2 is returned. How many digits is in 2? Let's convert it to a string, Fibonacci number, and then get the length of the string. And let's do plus I. Okay. So if this is the correct length, we'll leave the while and we return I. So at this point it will be 1 because we incremented. Alright, and if it's not good enough, we increment it again. So we check the second Fibonacci number, and the third, etc. So I think that's it. Does it pass? First one does not work, and we have an infinite loop. So what we're gonna do is debug to this and see what's going on. So number of digits equals 0, while it's not. We're looking for n is 1, so it's not 1. We expect it to get in plus I. Get Fibonacci number never stops because what happened? We were debugging and it jumped out. Get in there. Oh, n equals 0. So we gave it. Oh, I guess plus doesn't. Plus doesn't change the value of I. Is that what it is? Python increment int. Really? You can't increment with plus? Does not support plus, you have to do number plus equal 1. Alright. Python. Why do you compile? What does this even mean? So our test pass. And now in the main we want to know the index of the first number that has 1000 digits. Let's run it. Run all the tests in 25. Okay. And run this. Okay, this is taking a while. We'll add a little print here. So after the incrementation of I, what's the value? Okay, so as you can see, it gets really slow the higher we get. So what we need to do is some way to remember the previous Fibonacci numbers, because every time we try to call the Fibonacci number, it goes back all the way down to the first one. So they make like hundreds of calls, recursive calls, and this can't work. So as you can see, just computing one Fibonacci number takes forever. Let's close this. Okay. What we're gonna do is, because we don't have to, we could use some global variable here, and it will be like a set of all the previous Fibonacci numbers that we found, but we don't really like global variables. You can make it into a class or an object with a private variable. You know what we're gonna do for now is just prefix it with an underscore, which tells people when you use this module, never touch this variable, it's forbidden. or do it at your own risk. And this will be a dictionary of all the Fibonacci numbers that have already been found. And we'll remember them here. So, or is there not a easy way to, like, Python cache memoize is the correct term. Memoize function. Okay, so this guy just creates a variable before self memo. The feature known as decorator was added in Python 2.4, which allows you now to simply write the following to accomplish the same thing. Okay, that's interesting. So we can just use this, memoize. Let's try it. I never used it before. Memoize. So we don't need the global anymore. Create, install and import package memoize. Sure. Install that package. So the rule of programmation is to never reinvent the wheel when you don't have to. So now some smart people before us created a memoize decorator for this any function. We'll, I guess, remember every result that are made to the function. No module name memoize. But didn't you install it? Maybe what happened is it installed it on my computer, but not in the venv. Python venv. How do we install package? Installing package using it. Creating a virtual env, activating the virtual env like this, source and then activate. Okay. Source venv bin. There's no bin activate script maybe. Script activate. Okay. Activate the environment. Alright, just under here you can see on Windows it's scripts activate. Can confirm you're in the env, blah blah blah. We're Python, I don't really care about that. So you do pip install memoize. Memoize package. That's not the one. It's not a decorator. Pip. Rather, Python memoize decorator. Memoized. Creating signature preserving decorators through the decorator module. Make it possible to use memoized. So this might be the one. Install memoized. And pip just pip uninstall memo eyes. Do it. And pip install memo eyes. It's uppercase in this case. Pi memoize. Is it case sensitive? Uppercase. I don't know. Maybe it's not case sensitive. Alright, so we install the memoized package. Does it work? No. Set memo like this in the deck. We installed this one. Just memoized lowercase. We got import this name, memoized. Will it work? Module object is not callable. Let's read the doc. This repository has been deleted. Now lives there. Okay. Memoized. Okay, so I guess we have to import memoized from memoized. From memoized, import memoized. And we got it. So now let's remove the print here, make it cleaner, and gives us the 4000 something index. Does it work? Did we finish the puzzle? We did. Easy prey, solve 25 of the 50 easiest problems. That's embarrassing. We'll need to attack the other one. Alright. So, is there anything we can clean in the code? The tests are good. And what we can do to make sure nobody removes the memoize, we'll do a test that tests a big number. Like we saw before, at around 4D or something, it took forever to run. So let's make a test that gets the 50th Fibonacci number. And if well, for this case I'm the only one working on this code, but if I was in a team and someone would remove the memoized decorator, you'll see right away that the test takes forever to run, and hopefully you'll wake up and leave it as it is. So 50, it's whatever, we'll run it, and so now it's like reverse testing. We know that the code works, so we'll just write whatever and see the code fail and reuse that value. So if we run the test, everything passes. As you can see, it takes 0 milliseconds, so it's really fast. And if someone removes the memoize by accident, we'll see that the test takes forever to run. And look at what he changed, and hopefully we'll put it back, or well, or else you'll have to answer to webfox. So this is for the test, and let's quickly commit. Let me we solve the problem. Solve problem 25. Oops. Add everything. Then commit. Right, that's good. Now, this function, is there something that we can do to make it, I don't know, smaller or easier on the eyes? Get index of first Fibonacci number with n digits. Well, first we can inline this because it reads the same if we have the function get Fibonacci number or the variable Fibonacci number. So let's inline it. One occurrence. Okay, we should not inline this. Oh, yes, we can't. If it was ++I would still not inline it because it actually modifies the state and we don't want it to get lost in some one-liner. It would make it less readable. Well, I could rename it index, make it more obvious. So we return the index and it asks, the function gets an index, so it makes sense. Number of digits. I usually don't abbreviate my variable names, but for num or number, I kind of make an exception because it's so it's everywhere. So any programmer knows that NB means number and not, I don't know, nota bene or something. So, well, the number of digit is not n plus equal 1. Update the number of digits and return it. I guess it's clean enough. I don't see any obvious way to make it more cleaner. It's always useful to have a look at it and see if you can make it better. So that will be it. We can amend what we changed here, and then use the same commit message and like squashes it with the new modifications. So we still have just one commit that solves the problem 25. So never do this for a commit that you already pushed, but if it's just a local commit, it's perfectly okay. Activate environment, and that's it for today. We solved the puzzle. So see ya.